My name is LaloMorales. This is the Capstone project for EE 120 for the fall 2025 semester. Right here is my schematic. I interviewed my wife and my brother. My wife, she's Jessica. She wanted an easier solution. My brother wanted something a little more difficult with some extra security measures. Here are my assumptions list for Jessica's. She wants the confirm button mapped to P. So when she pushes it, the gate opens. N equals 2 for 2 incorrect limit. The idle flaw is implemented and auto close as long as P is 0. State transition diagram. So when she's in state 0, if P is pushed and it's the incorrect password, it goes to state 1, first warning. Same command, P again, password's entered again, and if it's incorrect, it goes into state 3 where it's locked out. Back at state 1, if the password is entered correctly, it goes into state 2 where the gate opens, no warning light. Loops if P is 1 and F is 1, and same with P is 1 and F is 0, stays in state 2. The only way to get back to state 0 is to let go of P, that the flaw that we implemented. And yeah, and there's a reset, asynchronous reset to reset the whole thing. Here's the state transition table. My K-maps and the equations up here. I got the final equations. D1 is Q1 and Q0, or Q1 not and Q0 and P, or P and F and Q0 not. 3 AND gates, 1 OR gate. Boom, boom. And inverters for Q1, Q0, and F. Inverters over here. For D0, Q1 and Q0, or P and F not and Q1 not. So we need the 2 AND gates, 1 OR gate, inverted for Q1 and F not, right here. The output logic is Q1 and Q0 not, right here. And for output for W, there's no gates needed. 2 D flip-flops, we have D0 and D1 right here, both connected to a single clock input over here with the tunnel, boom. And this is the other design for my brother. I went with my wife's design just because she's my wife. Here's the criteria right here. Ease of use, 25%, 25 for security and features, 20 for implementation logic, 15 for testing simplicity, and 15 for extendability. I put in some numbers for each of their designs, and my wife designed one. It was just a little simpler and quicker to do. The building design, here it is right here. And digital, I added some test data right here so we can test all the different states. And when you run the test, we're getting all greens. Everything is passing. Those tests are right there, passing. And I also put them in right here. All right, so how it works, when P, the password is being entered, F is the password's correct, reset clock. When the reset's there, G and 0 are supposed to be 0, they are 0. 0, 0, 0, and 1 for clock are still at 0. 1, 1, and 0 and up. We got the gate open right here. 1, 1, 0 and up. Do it again on the next clock, stays open. 0, 0, 0 on the next clock is going to close the gate. Same thing on another clock, gate stays closed. Wrong password entered on the clock, warning light goes on. If we do it again, warning light stays on. You do it again, you're locked out. So then you have to try here. Nope. And locked out, my friend. The only way to get out of the lockout is hit the reset, hit the clock. And that's my circuit. Thank you.